Ah, well, good morning or afternoon or whenever you're listening to me, Trinity Classical Academy. This is your host at Ground Zero of the Toilet Paper Zombie Apocalypse, Magister Bourgeois. Let's review the practice checkpoint that you did. Um, and while we review, I'm going to also discuss some of the ways that you can prepare for the upcoming checkpoint. Once again, you can always reach out to me if you have the questions. I think I'm gonna do this and label the number problem so you can hopefully find the one that you're looking for. So number one, the answer is sphere. The name of the solid that does not have a base is a sphere. But I will say this, you're going to have to know what the net of a solid looks like. So look at that first chapter again and just make sure you know, okay, when a prism is unfolded, what does it look like? When a pyramid's unfolded, what does it look like? A cone, a cylinder, what do those look like when they're completely flat and unfolded from a piece of paper? Number two, the cross section formed, that would be a rectangle. A rectangle. It's a rectangular pyramid, so you can't say it's a square because you don't know that it's a square. It looks kind of squarish to me, but we can't be certain. All right. Number three. I really hate that it does that. Number three, find the volume and the surface area of each solid. You may use a calculator and use 3.14 to approximate your pi. So volume and surface area. So when you do this, guys, hopefully you remember to do volume and surface area, both. So the volume of the cylinder is going to be the area of a circle, pi r squared, times how high it is, right? So the r is 4 centimeters, and the height is 14, so we take 4 squared, that's 16. 16 times the pi and the height. Oops, I didn't turn on my calculator app yet. So 16 times 3.14 times 14 is the height. The volume should be 703.36. I'm looking at the answer key just to make sure I'm right. Yep, 703.36. .36 centimeters cubed, cubic centimeters. The surface area. That's going to be, we have the top and the bottom, which is the area of the circle. So that's going to be pi r squared. But there's two of those circles, so it's going to be 2 pi r squared. Right? So 2 pi r squared is the surface area of the circles, and then we're going to add the curved surface, which should have had this bookmarked. The curved surface is going to be pi, I think it's 2 pi RH. Am I right? Yeah, 2 pi RH is the curved surface. So we have the cylinder, dot, dot, dot. So this curvy surface, rainbow pen, that goes around, is this part right here. 2 pi r times how high it is. All right, so we're going to add those, plug in those numbers in our calculator. So remember, r is 4. So we have, for the top part, I'm just going to doodle it over here. So the top part, we have 2 times 3.14 times 16 is 100.48. And our units should be square centimeters, not cubic centimeters. And then the second part, 2 times 3.14 times 4 times 14, how high it is going to be 351.68. Cubic centimeters. We're going to add these two together. We're going to get 452.16. Hopefully I got that right. Let me check the answer. If I got it wrong, I guess I'll have to redo it. Where am I? Yeah, got it right. Okay. So these are my answers. Woo! All right. So if you're inclined, you can feel free. I cannot skip around. I have to record the entire video. I wish I could record this at 2.5 times speed, but you have the luxury of moving faster than me. So you can skip around and find the problems that really stuck you. I thought I moved this whiteboard all the way over as far as it would go, but apparently I did not. All right. Quattro. We're dealing with a sphere with a radius of 9. So the volume of a sphere, 4/3 pi radius cubed. Is that right? Yes, that's right. So let's do it. Radius is 9. 9 times 9 times 9 is, I think it's 200 or 70, 700, and I don't know. 729. Yeah, I knew it was something around there. 729 times 3.14 times 4 equals that, divided by 3 equals 3,052.08. 0.08. Are we in centimeters still? Cubic centimeters. Yep. Centimeters. That's terrible. Centimeters. Cubic. There we go. Next, we're dealing with the surface area. The surface area is the same as a circle, pi r squared, except it's 4 times as big as a circle. Take the area of the circle, put a 4 in front of it, you're golden. Righty-ho. So again, we're dealing with the radius is 9, 9 squared is 81, 81 times pi times 4 on my calculator. 1,017.36 centimeters squared. Let me look at the answer key, make sure I'm not wrong. Got it. Decimal points are tricky on this little touch screen majigger, but hopefully you can see that and know that there's a decimal point there. Point. Groovy? Groovy. Proceeding forward. Number 5. We're dealing with a pyramid, or excuse me, a cone. So the volume of a cone is 1/3 of the volume of a cylinder. Remember? That's my mnemonic. If I remember the volume of the cylinder, I remember the cone. And so the volume of the cylinder is base times the height. The base is pi r squared, because it's a circle on the bottom, but it's 1/3 as big. That's how I put together that formula. So the radius, since the diameter across is 40, the radius will be 20. This is a big cone, you guys. Big cone. So 20 squared times 21. If it were me doing this test, I would not want to approximate pi. I would just say leave it in terms of pi, but whatever. I'm just going to plug these into the calculator. 3.14 divided by 3, so that's 1/3 pi, is 3.14 divided by 3, times 20 squared, times 400. Let's try to start over. I need to clear my computer. 20 squared times 3.14 equals, divided by 3 equals, times 21 equals, I get 8,792, still in centimeters, cubic centimeters. Let me double check, make sure I'm not wrong. Yep, 8792 cubic centimeters. And now the surface area. So the surface area is tricky. We have two parts. Let's draw it. Or you don't have to, but I kind of do. So we have two parts, right? We've got this curvy part, and we've got this part right here, this bottom circle. So this bottom circle, those two parts, we're going to add them together. So the bottom circle is pi r squared, the area of a circle, plus the curly-durly cone part. Remember, since it's round, it's got to have pi in it. I know that much. It's got that slant height. That weird. That was terrible. The slant height thingamajigger. And it's got to have the radius involved because we need to know how wide it is. So they give it, I'll give it in order. Pi r slant height. I just kind of pieced it together from memory using, I knew it had pieces to it. Let's do these pieces separately. The radius squared is 20, so 20 times 20 is 400 times pi. The radius down here is 20 times the slant height, which is 29, so 20 times 29. 20 times 29 equals 580. 580 times pi. Add these together, you get 980 times pi. Now I'm going to multiply that, so 980 times 3.14 equals 3,077.2. That's my answer. Centimeters squared. If you multiply these out first and add them together, you should still come up with this answer, 3,077.2. 400 times 3.14 equals 1256, 1,256. I'm going to put that in memory. Memory plus, and then 580 times 3.14 equals 1,821.2 plus memory recall equals, I still get the same answer, 3,077.2, and that is the correct answer. If you got that answer, consider yourself correct. Oh, we reached the bottom. See, I tried to slide my dealie over all the way up as high and as far to the left as I would go. And then it seems to be weird. Okay. Fellas and dames, we are on number 6. So, solve. Show your work. You may use a calculator and use 3.14 to approximate pi. A square pyramid has a volume of 507 cubic feet. Given that its height is 9 feet, what is the length of the base of the pyramid? So we're trying to solve the missing value. So they give us the volume and they give us the height, and we're supposed to solve the length of the base. Tricky, tricky. So volume equals the base times the height. In this case, because we're dealing with a square, the base is going to be length times length. So it's going to be length squared. That's an L, not an upside down candy cane. So it's going to be length squared. So let's plug in what we know and we'll solve. So we know the volume is 507. 507. Let's try that again. Equals the unknown value, length squared, times the height, which is 9 feet. So I'm going to divide both sides by 9. I don't know about you, but that seems like the next step. Divide both sides by 9. We get 56 1/3. equals L squared. So whatever answer you have on your calculator, 56.333333, just find the square root. However your calculator does that, at this point, if you haven't already figured out how your calculator works, you should have contacted me sooner. Square root equals, I get 7.505 and some change. Somehow I feel like anytime I get a decimal point answer, I feel like it's generally not right, but let's see. So 7.505 and some change, so 7.51, why not? Or whatever, is approximately equal to my length. Checking the answer key. If I get this wrong, well, then I guess I'll have to figure out why I got it wrong. We'll figure it out together. What number are we on? 6. 13 feet. We got it wrong. Oh, 1/3. Dad blast it. I got the volume wrong. This is the volume of, I got my formula wrong. Whoopsies. All right, back up. What did I get wrong? It's 1/3 the base times the height. This is a pyramid, not a prism. Boo. Okay, sorry guys. That's what I got wrong. Okay, maybe some of you got this wrong too. I empathize with you guys. I empathize with you guys. So far, so I just want to point this out. So far, nobody has gotten a perfect score on any of the checkpoints. So that is what it is. I don't know. Let's do this again. So 1/3, so instead of dividing both sides by 9, I should have divided both sides by 3. Because I have this 1/3. No, hang on. I would multiply both sides by, so, okay. I do divide by 3 because I combine these two and I get 507, combined like terms, L squared times 3. Then I divide both sides by 3. So 507 divided by 3. Wake up, calculator. Equals 169. Equals L squared. I square root both sides. So 169. No. Square root 13 equals L. That's what I'm talking about, guys. If you find that your answer is some wonky decimal, it's probably wrong. And didn't I say that when I got that wonky decimal, 7.5 and some change? I'm like, I don't know, guys. I think this is wrong because it's a decimal. Like generally when they have you solve for a hidden value, when they have you solve for a missing dimension, it's probably going to be a whole number. So if you find that you get some weird decimal point on the checkpoint, just take a minute, look at your work again, see if you didn't do something, miss a thing, like I missed this part of this formula. Because like I said, I'm solving this live. This is game day. I'm doing it live with you guys. 45 minutes time limit. I want to see how well do I do, and to kind of work you through my processing. This is how I work on checkpoint day, which I don't have checkpoints very often anymore. But on test day, I check my work, and if something just doesn't smell right, I'm going to look at it again. And I knew that 7.5 didn't smell right. It just seemed wrong, because why would they make it a decimal and not a whole number? I know these test writers, they don't like decimals, they like whole numbers. So I saw a decimal, I was like, I think this is wrong. So 7. The lateral surface area of a cone is 343.83 square centimeters, and the radius of the base is 7.3 centimeters. What is the slant height? Cool. I'm going to draw this for the benefit of everybody. ... So they say the whole surface area is 343.83. The radius is 7.3. And we're trying to find the swirly, the slant height. Well, we know the surface area. So we're not terribly concerned with the base because they didn't tell us the base. They told us the rainbow pen side, the swirly round part, right? So swirly round part. That formula is off of memory, pi times the radius times the slant height. So they gave us the surface area of the lateral 343.83 343 equals pi times the radius, which is 7.3, times that thing. Sorry, I meant to write in that color. You get it. So I'm going to go ahead and just divide both sides by 7.3. I'm going to take pi times 7.3. Let's do that. Take pi times 7.3 equals times 3.14. If I use the approximation, it keeps me in good whole numbers. So 22.922. Now I'm going to divide both sides by that. So reciprocate on my calculator, times 343.83. So I divide both sides by that number, and look, I get exactly a whole beautiful even number. 15 equals lateral slant height thing. I feel very strongly confident about that because when I divide both sides by 22.922, I get 15. A whole number tells me that this answer is probably correct. 15 centimeters, yep. Don't forget to label your units. Woof, okay. Halfway, so I'm looking at it, looking at the clock. I'm halfway done with my time on this checkpoint. So I'm hurrying up. Number 8, solve, show your work. You can use a calculator, use 3.14 as approximation for pi. Okay. Emily plans to make some spherical ornaments for decorations. Each spherical ornament has a radius of 1.5 centimeters. A, calculate the surface area. Calculate the surface area of the 50 spherical ornaments. So I'm just going to calculate one surface area and I'm going to multiply it by 50. No sweat. So surface area of a sphere, do you remember it? I hope so. Surface area of the sphere is 4 times the surface area times the area of a circle, 4 pi r squared. R is 1.5 inches. So it's a 3-inch diameter ball that she's making. I'm going to plug this into my calculator. 1 5/10 squared is 2.25. I should have been able to figure that out with my head, but you know what? If I have a calculator, I'm using it, so whatever. Times 3.14 times 4 equals 28.26. However, we have 50 globes. 50 times my answer of 28.26. I suppose the other way you could have done it was you could have substituted this 4 and made that a 200, and then you'd be taking 4 times 50. So whatever. So that times 50 equals 1,413, and we're doing inches squared. I'm going to check my answer, see if that's right. Yes, inches squared. B, find the volume of 50. All right. So the volume equals 4/3 pi r cubed. So again, my r is 1.5. 1.5 times 1.5 times 1.5 equals 3.375 times 4 equals 13.5 times 3.14 equals 42.39 divided by 3 because it's 4/3. If you want to do 4 times 4/3, you sure can. If that's easier on your calculator, I like to first multiply by 4 and then divide by 3. Personally, that's how I like to do my keystrokes. So I get 14.13 inches cubic inches. Multiply that by 50, and I get 706.5 cubic inches. 706.5 cubic inches. Am I right? What number am I on? 8. Yay! Ding, 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 ding. That is number 8, A and B. Do I have enough space for number 9? I do. Number 9, Marcus made a sand pile in the shape of a cone, as shown in the diagram. What is the volume of the conical sand pile? Cool. Volume. So the volume of So the volume of a sand pile that is shaped like a cone is equal to 1/3. Let's not forget it this time, Magister Bourgeois. 1/3 of the base, which is pi r squared. The base is a circle, so base is pi r squared, times the height. Height is 24. No, come on now. Height is 24. Radius is half of 36, which would be, hang on, don't tell me. 18. Is that right? 15, 16, 17, 18. I have a calculator, I could use it. Let's just use it. 36 divided by 2. 18 is right. I don't know why, I just didn't feel confident. All right, so 18 squared. Boop, 324 times 24 equals 7,776. Take that times 3.14 and then divide that by 3. And I get 8,138.88. Writing and stuff. Let's see if I'm right. Oops. 8,138. Am I supposed to round to the nearest anything? I don't know. We'll just leave it. 0.88. Checking the book. 9A. Yes, 8138.88. Label the units. Feet cubic. Holy crackazoles, this guy seriously made a 20-foot tall sand pile? Marcus, what are you doing? This kid's a psycho. Using the same volume of sand, Marcus made another conical sand pile with a base diameter of a base diameter of length 24 feet. What is the height of this sand pile? So he took that sand and he rearranged it into a narrower cone somehow. I don't know, maybe he's in like a national sand castle building competition. So now they give us the volume. They give us the volume is this answer. So this answer, 8,001. So if you get A wrong, guys, you're definitely getting B wrong. You cannot possibly get B correct with an incorrect input up here, unless somehow you really just randomly made it. I don't know. I'm gonna go ahead and say it's not possible. If you do, you are cheating somehow. Made another conical sand pile. This time it's narrower, so it's a more taller, skinnier, coney thing with the same amount of sand. And it's 24 feet across, which means the radius is 12. That's half of that. So Equals 1/3 times pi. We're trying to find the height. So they gave us the radius is 12. 12 squared. 12 squared equals 144. I'm going to go ahead and write 144. By the way, guys, this is problem number 9. Sorry. 144 times the height. We don't know what the height is. Algebra time, you guys. Multiply both sides by, let's just go ahead and wrap this up into a nice neat package. 144 divided by 3 times 3.14 is 150 and 72 tenths. Times h. Now we can divide both sides by 150.72. We're going to get the nice, neat, even number. 54 equals h. It comes out perfectly. Perfectly. No decimals. That tells me I'm probably right. And that's, oh, let me label my units before I move on. My units are feet. Straight up feet, not squared, because it's height. This is linear feet. Not cubic, not square. Linear. All right. 54 feet is the correct response. Ding, ding, ding. All right. I think I'm out of whiteboard space here. Nope, I have a little more. 10. 10. The diagram shows the cross-section of a pipe 1.5 inches thick with an inside diameter of 4 inches. Diameter, not radius. The pipe is 22 inches long. Find the area of the shaded part as shown. So they shade the little edge of this circle, right? Oh dear. Okay, so I'm going to redraw this as best I can. So we have a circle, we have another circle. This circle has a radius of 2 because the diameter is 4. And big circle has a radius of 2 plus 1.5. So that this is 3.5. So here's what we go on do. We're going to find the area of big circle, and we're going to subtract. Which one of these is red? Tell me the color. Are you red? Red, okay. Red is a negative number, right? We're going to subtract this surface area from the big, not surface area, but the big area of a circle, so that we can find the area of the middle piece. So the area of a circle is pi r squared. For the big circle, we have pi times 3.5 squared. So 3.5 squared is 12.25. You can multiply it by pi right now if you want to. I'm going to leave pi sitting right there, and I'm going to find the area of small circle. So negative circle, pi r squared. The r is 2, so 2 squared is 4, so that's 4 pi. So 12.25 pi minus 4 pi equals 8.25 pi. Now 8.25 times pi times 3.14 is 25.905, which, and that would be inches, square inches. So I'm going to look that up, see if that's right. It is correct. I win. That was A. Number B. Find the volume of the pipe. I wonder, I think they mean not the whole cylinder, but the volume of the pipe. I think that's what they mean. So similarly, we have to take the right, so we got this pipey thing, and it's got these little dotted line thingies. It's got this little piece. I think it's just the volume of the actual pipe itself. So we have to take the volume of the big cylinder minus the volume of the little cylinder. Guys, I'm going to show you a shortcut. If you calculated the whole volume of big cylinder, if you subtract little cylinder away from big cylinder, you'll get the right answer. I'm going to show you a shortcut because we already calculated the shaded region, you guys. So we can just take this shaded region, multiply it by the height, and we're done. I'm pretty sure this is going to work. Because remember, the volume of anything is just the area of its bottom times how high it is, right? Not you. You. So if I have a circle, a cylinder, right? I don't know, that was terrible. If I have a cylinder, how do cylinders work? Like that. If I have a cylinder, I just find the area of this circle, pi r squared, the base, pi r squared, and I multiply it by how high it is. So it's like I have a circle, and how many circles does it take to get to the top of this circle? And that's my volume. Now, whatever this shape is, if it's a wonky shape, and it goes up into a wonky shape, that's the same. The basic formula is still the same. The volume equals the base times the height. So as long as it's the same throughout, if I've got a wonky shape. So one of my students sent me in the chat, I don't know if I should out her. Brianna, it was Brianna. She asked me, how do I find the surface area of the White House? And I'm like, I could do that. Whatever the wonky shape is, it's just a composite solid. You calculate the surface area of something and you subtract what's missing. So like if it's a wonky shape, you subtract what the wonky shape is or add a wonky shape to another wonky shape. Any figure you can pretty much chop up into little bits and calculate the area, the surface area or the volume of the little bits, and you should be able to piece together the volume of the White House. Now, I don't have its dimensions, but that's generally how it goes. Having said that, looking at this pipe, we know what the base is. We've already calculated it.